Okay, we are recording. All right, so I'm actually going to start this by having you pay attention to the projector. And this won't be on camera except for my voice. And what I'm going to do is I'm going to walk us through the syllabus very quickly because I don't want to take too much time doing that. I want to make sure everyone knows where to go to get the information for the class. So let me take you to Northwest Vista's main website. Maybe. All right, so assuming that you can get here, you go to this login to ACES, and then you log in here. If you don't know your login information, I believe you can get your information right here. And let me see if I can remember this password. Oh. How many of you know how to do this already? Show of hands. Okay. Anyone have no idea? It's okay, just show me your hands now if you have not been there. So we're good? All right, good. Go to courses. When you all go in, does it still say fall 2015 and you have to drop down? They said they were going to fix that last semester. They never did. So make sure you pick that. So I'm teaching college algebra, this class, Cal 1, Cal 2, Cal 3. But this is my only summer 2 class. Those other 3 are all online classes. Okay, so this is our main shell here, and you all familiar with the inbox? If I send an email to the class, it'll appear over here on the left side, and that's where we communicate. All right. If you want to send me a message saying I'm not going to be in class, hey, I'm going to miss the test, something needs to come officially through here. It cannot come from your Hotmail account, your Gmail account. It's the only thing that's considered official, all right? So you just go in here, compose a message. I'm not going to show you all of this, but find your course, select me out of the list of, it'll say instructors, and then find me on there and click and send me your message, all right? Okay, so back to the course. And I think I'm going to switch this to a student view so it'll look like it looks like for you. Okay, it should look like that when you're in there, except for this pink border, it won't be there. All right, so this is our main home page. We have the course syllabus. We have what I'm calling the class packet, the schedule, the videos, what that camera's recording will be here, and then file. So let me go through these. We'll start with the course syllabus. And my name is Robert D. Giovanni. You can call me anything respectable. Just don't call me Bob or Bobby. I don't go by Bob or Bobby. Robert's fine. Mr. D's fine. Whatever you're comfortable with. I am in my office, okay, which is in JH 1110. That's the first floor of this building. It's hard to get to the first floor, right, which is kind of why I chose the office I chose. You have to go out into that elevator shaft all the way down and then back in, all right? And then you go find that room, and that's where I'll be, all right? Now, I will be in that office Monday, Tuesday, Wednesday, and Thursday, so every day before your class from 11 to 12:30, and then I'll come up here. So I'm there for about an hour and a half before class. Unfortunately, after class, if you want to meet with me afterward, we just have to make an appointment, all right? I know that doesn't work for everybody, but hopefully enough of you will take advantage of that. Office hours, if you don't know what those are times I say I'm going to be there that you can come in and ask questions. If you want to sit down and go over some homework problems, you know, if you're getting ready for the test and you want to ask me anything, that's the time, all right? I also provide you my cell phone number. Now, that's not the official way to communicate with me, right? It's all through Canvas, but if it's something quick that you just have a quick question on, you can call me, you can text me. I just ask that if you text me, you let me know who you are in the text. All right, so just say, this is so-and-so from Math 1314, and that should be enough for me to identify you. I don't really have a time where I say don't text me here or don't call me. 24 hours a day, but if I don't respond, it's just give me some time. And especially on the text. I think we all probably share this problem. Someone texts you, you look at it, and you forget about it later. That only happens to me, right? So as far as I know, there's not a way on my phone easily to flag a text to go back as unread, right? You can't do an unread on a text. If you can do it, let me know because I need to figure that out. So sometimes I'll read a text and then I just forget about it and that's it. So sorry. All right, what else up here? We meet from 12:40 to 2:40. It's a 2-hour time slot here. We'll see how things go. We might do a 5-10 minute break in the middle. We'll just see how you all feel, all right? We meet all the way, 5 weeks, right? It's a 5-week course. So we're going to meet between now and August 11th. The required materials, did anyone get the materials for the class? Do you have them with you? What does it look like? That's it? Okay, so may I? Oh, wow, you have both of them, yes. So you're supposed to get this packet, which was at the bookstore. How much was this? $8. It's going to set you back. This? 30.
I spent $10 on it. I bought it off of that.
Okay, yeah, don't spend $30 on this. I don't think.
Yeah, it's 15 to 20 max.
Okay, all right. As long as you can figure out how to use it. I don't care if you have a fancier calculator. You just need to have a calculator that does everything this one does. And also, when I'm helping people out with the proper keystrokes on the calculator, I'll be going off of this. So if you need help, I'll have to come around and help. All right? So those are the two required things for the class. Hopefully that won't set you back too much. Now on the packet, you do not have to buy the packet. If you want to print it yourself, then it's online. Okay, it's posted up there. And they should be the same, but there's no guarantee. That was made a long time ago, and the one I have might be a little bit more current. It might have some typo fixes, but we'll just have to see. That's the only thing you need. Okay, that packet has the problems I'm going to do in class. Any notes are all there, and then your homework assignments are in that packet. So every day I'll go through material, and then at the end of that section there's homework problems. When I say, hey, go home, make sure you do your homework, I'm referring to the homework problems in the packet. Right? Don't try and do the homework, don't try and do your work in the packet. There's not enough space for you to do that. On separate paper, do all your homework. All right? All right, course objectives. Maybe I should have started by making sure everyone's in the right class. There are two college algebras. There's Math 1314, which is this course, and there's Math 1414. Okay, let me tell you what 1414 is first. 1414 is college algebra for students who are going to go on and take pre-calculus and then possibly go into Calculus 1 and Calculus 2. So we call that our STEM tracks, science, technology, engineering, mathematics majors. If you need to take pre-cal, you are in the wrong class. So, anybody think they're in the wrong class? Sure? You do not want to have to do this whole thing and then wind up having to take 1414. We're all comfortable? All right. No questions on that? All right, so you can read this about the objectives, the outcomes, and I'll just get down to the grade. So there's, this is a true college level math class, which means that there's no IP. If you took any developmental math courses, there is a grade called an IP, which is like an in-progress grade. It's basically a student who doesn't pass, but they just kind of tell them nicely that you didn't pass, so they give you an IP. We don't have that here. I only have at the end of the semester the option of A, B, C, D, and F, and that's it. So we're going to go standard grading scales, 90 to 100 A, 80 to 90 B, so on and so forth. And I do round up, okay, so don't worry about that. Students inevitably will ask me about a grade called an I. Are you familiar with an I? Yes? Okay, so an I is called an incomplete, and it is a very difficult grade to actually get. Let me give you an example of something that would warrant an I. You're on the way to the final exam. You're passing the class. You're just come and take the final. You're passing the class. You get into a car accident. You break your leg. You can't come to the final. All right? Then we give you an I. Then we give you 120 days to take that final, something like that. It has to be signed off by me, has to be signed off by the chair of the department, has to be signed off by the vice president of the college. It's very difficult to get all three people to sign off on it if you just didn't show up, or just you were failing and you didn't drop in time. It's not going to happen. So if you don't want to be in this class, if you don't like the pace of the class, it's too fast, whatever, you don't like me, whatever it is, you need to just withdraw from the course, all right? All right, so how will I quantify your grade? We're going to do quizzes and homework. Maybe I can make this a little bit bigger. Quizzes and homework, 15% of the grade. So my idea there is that you're going to have homework every day, right, out of your packet. You're going to write that homework down. I want you to bring that with you every class for the entire semester. So the homework you do tonight, you're going to bring that 5 days from now, 10 days from now. And at random points, I may just do like a homework check. And I'm going to go around the room while you're doing classwork, and I'm just going to check grades off. Just that you've shown effort, okay? That I can see that you've done it. I'm not going to be like, you skipped that one, it's wrong. You get a 0. It's an effort thing, all right? So if you're doing your homework, putting in the honest effort to it, that's an easy grade. Quizzes, maybe you may have one every day. You may have 2 a day. They could be, everyone take everything off your desk. Everyone's going to do their own quiz. It could be a group quiz. It could be an attendance grade that you showed up. That's a quiz grade, okay? Like if I start seeing that people are starting to not show up, I'll just give a quiz that day on attendance. And then you start taking 0s for that, all right? Questions on that? Exams, you're going to have a total of 4 exams. 3 of them are worth 20%. The final exam is worth 25. And each of those exams should be pretty self-contained. So like exam 1 obviously will cover everything that we do before that exam. Exam 2 should cover everything after exam 1 up to exam 2. Exam 3 is everything between exam 2 and exam 3. Make sense? The final is going to have kind of a blend of all of them. It's cumulative, I guess you could say, because our final is actually 2 days after exam 3. So there's not a lot of material that I could separate onto the final. Attendance. So because this is a summer course, you can miss a maximum of 2 classes. All right, 2 unexcused absences. That means you missed class, you don't have to tell me why, you just weren't here. No big deal, all right? You go watch the video and all's good, right? Now, if you have excused absences, that's something else, but that we have to have documentation, I was doctor appointment, whatever it is, right? If you stop attending class for any reason, you need to contact me to be officially withdrawn from the course. So if you just decide, after today, I'm not going back, right? Then you do not assume that I will just drop you from the course. You have to go in there and actually withdraw yourself, all right? If you don't drop yourself or you don't withdraw and just trust that I'm going to do your paperwork for you, then you're going to wind up with an F at the end of the semester. That's a lesson you should learn in college, right? If you enroll in a course, don't want to go anymore, you have to unenroll. If not, the professor's just going to give you a big fat F at the end. You don't want that on your transcript. On the other hand, if you do miss more than 2 classes, I may drop you. It's my prerogative then. So even if you've got A's on all your exams and you miss 3 classes, I can still drop you from the course for non-participation. With me? 6 drop rule. This is a Texas law about, boy, it happened back in 2007. So anyone know what that law is about? 6 drop rule? Yeah, and in Texas, if you're in a public institution, that means taxpayers are funding the institution, which this is, then you can only drop 6 courses in your entire undergraduate career. Reason? People were getting financial aid, going to school, and not going to school, and abusing the system. So you basically get six drops, and that's it. After that, you have to start paying out-of-state tuition. So just be aware of that going into your college courses. You're allowed to drop courses, but there's a counter, and they're keeping track of how many you've dropped. All right, now tutoring. If at any point in this summer you need help, of course I'm available in my office. You can call me, whatever. But right across the hall is a tutoring lab. They've got pretty good hours. Like they're open 8 a.m. to like 9 p.m. or something. They've got good hours. Just go over there, room 316, and you should be able to go in there and get some help, all right? And I believe every tutor in there should be able to help you with this material. All right, SOBI statement. Now, this is a lot of information right here. So let me just kind of summarize what I think the SOBI statement is. We just have to pay attention, all right, to each other, to what's going on, things that are happening in the classroom, things that are happening outside the classroom in the hallways, right? I mean, yes, this is a crazy world we live in, right? So we want to pay attention to each other, and if we see anything unusual that makes you feel uncomfortable, to not just sit there and not say anything. You know, speak out, talk to me, talk to someone in the math department, all right? If someone's making you feel uncomfortable. Yes? Okay. I've been teaching for a long time, and for the probably past 10 to 12 years, on the first day of class, I always talk about active shooters. And it used to, like, 8 years ago, it used to be like my students were like, dude, this guy is weird. Like, he's sitting there talking about what do you do if someone's like shooting up the building. And now it's like I talk about, it's like, it like bothers people because it's so real. So look. Oh yes, okay. That is not an exit. This is an exit, all right? There's an awning right here. It's probably about 12 feet, but it's a survivable jump, and from there you could probably survive the next jump too. So that is an exit. And these chairs would be going through those windows first, right? So that is an option. The other option is that door, right? So there's a saying, it's something like luck is, I'm going to get this wrong, but like luck is preparation meets opportunity. Have you ever heard that before? Yeah, something like that. So we just don't want to be completely ignorant to what our options are should we ever have to face something like that. All right? But this is 30 feet straight down concrete, okay? We got lucky. There's some rooms in this building that are, you know, there's no awning there. It's behavior policy. All right, so people do not like this part of my syllabus. I don't have any tolerance for cell phones. I understand that it's difficult for 2 hours out of a 24-hour day. That's 1/12 of the day, right? 1/12. That you are being asked to put it away and just disconnect from it, all right? I don't want to see cell phones out. I don't want you to be texting underneath the table. You know, I want everything put away. You focused on what's going on in here. If you have an important text, you have to go update your status on some social site, whatever it is, just get up and go do it in the hallway. If you need to make a phone call, just go do it in the hallway. I just don't want it taking place in class, all right? Now the penalty for that, for texting, using your phone, or sleeping, because I don't tolerate sleeping either, is what? 10 points on your next exam for each offense. So that means exam 1's coming up. If you were to be texting in here today, I would identify who you are. I would embarrass you in front of everyone. I would ask you to leave because I'm going to count you absent for the day, and I would go in and I would dock you 10 points off your next exam. So any volunteers to be my first victim? No?
Wouldn't we be dropped from the course because if we're absent on the first day?
Technically, you know, let's try that. Someone take out their phone. Let's. No, I wouldn't do that. I would let you come back. Okay, so I guess I just want you to pay attention. It's never really ever been the student that knows everything that's on the phone. It's always the student that can't seem to focus and hates math and just would rather be everywhere else, but signed up for this class and they're here. So I want it all put away. You think you can handle that? If you can't, if you know right now, look, I'm paying to go to college and I should be able to have my phone out, we can get you transferred into another class. No? I like that argument too, you know, like I'm paying to be here, but they still let me make the rules for my class, so that's my rule. I think that they'll take that away from me one day. All right, so this is our layout. Now this is our schedule. I have to put a schedule in the syllabus, but this is not the one I want you to use because it's not very user-friendly. So if we close this syllabus, oh, there's a bunch of stuff at the end that I have no control over. The college automatically puts that in there, so I will not read through that. All right, so the schedule here, you can print this out. I just updated this morning, so if you were looking at it yesterday, it's been modified. It's a little bit easier to read if you print it. I recommend you just print it out and put it in put it where you're going to do all your homework or something. Tape it to the front of the folder. I have mine right here on this little manila folder here. So that's just the layout. This is the plan, okay? It's a tentative schedule, which means that it could change. We could fall behind. We could get ahead. This is what I'm going to shoot for, all right? So it's broken down by days. Today is Monday, the 11th. We're going to go over the syllabus, which we're doing. We're going to talk about fractions and expressions, order of operations, and we're going to review linear equations. This corresponds to pages 5 through 8 and 9 through 12 in that packet. That's what I'm going to cover. And so when you get to page 12, I believe page 13 has the homework for those two, or for these sections, fractions and order of operations, and linear equations. And then we come in here on Tuesday, which is tomorrow. We're going to get right into the next thing. And then we get into the next thing. And then we have our first test next Tuesday. So we already have a test. It's 6 days away. Notice also that I have next Monday, we will be doing a little review. All right, so we're going to do equations of lines and applications, which is going to be a continuation of what we did this Thursday. And then whatever time is left over, we'll talk about the exam. But I would not expect like a formal handout review. Most likely what I'll do is tell you, okay, let's look back at these homework problems and let's focus on these for the test. So I'll try and kind of narrow it in a little bit for you, but I'm not going to just spoon feed you a review that's an exact copy of a test that I'm just going to change numbers on. You still have to have a general idea of what you've done for all the homework problems. But if you do your homework problems, I promise you, bless you, if you do your homework problems, I will not surprise you with anything that you don't see on homework. So I'm not going to just pull some problem that's one of my favorite problems that I never showed you. I'm not just going to pull that out and throw it on a test. All right? Sound fair? Okay. And we keep grinding away, and then we get exam 2. Exam 2, there is an entire day dedicated for reviewing for that test. Sometimes, depending on the class, sometimes what I've done in the past, and again, this is so hard to predict how things are going to go for us. I've done this before where if we have an entire day for a test, what I'll do is I'll offer you the test on this day. And you come in on this day and you take the test, and I call it a no-risk test, meaning you sit down, you take the test, and if you fail it or you just are not happy with it, you come back the next class and you take that one, and that one's your grade. All right? So it's kind of like, there's a lot of problems that students have with anxiety when it comes to exams. And when I do that kind of no-risk test, you can kind of like exhale and relax and know that no matter what, you get another chance if you need one. So depending on time, we may do that for exam 2, and I believe exam 3 is set up the same way. But for the final, we all have to come in and take the final the same day. All right, so. And the final is just the last day of class here. So there's not like finals week like there is in a fall and spring semester. There's not a special week just for finals. It's just the last day that we meet, which is August 11th. Good? Questions? All right, the class packet, again, you can download this. It's a PDF, so you can print that out. What I'm doing is I'm printing out just what I'm going to cover that day, and I'm just bringing that with me. And then I'm just going to continue to do that. For you, you can do whatever. Just make sure you bring what we're covering for the next class. Bring it with you. Because I will tell you during class, like, you know what, I'm going to do problems 1 and 5. Why don't you do 2 and 6? Y'all work in groups on 2 and 6. And if you don't have the packet, then you don't know what's going on. All right, files. Right now, the packet is in here, and then the schedule, which you could get to those already through those links. But there's a bunch of other stuff in here, miscellaneous stuff. And I'll be quite honest with you, I haven't looked through all of these. These were given to me about, 4 days ago. And I think those are just like additional things that I can throw in to the section for like additional problems. So we're nowhere near the beginning of this, page 39. So when we get to page 39, we'll open that up and take a look at it. I said the videos will be on YouTube. So when you click on that, did y'all see the link I clicked on there? Videos of class lectures. I always have students that'll email me and be like, hey, didn't you say you had videos or something like that? And I'll be like, yes. Okay, do you see where it is? They don't know where it is. Y'all see it? Yes? Just click on that. That'll take you to YouTube. And then the videos will start to appear here, and I'll have them listed like this. It'll be like day 1. It'll say day 1, and then usually like what topics we covered or something like that. The sections out of the book, or out of the packet. And that's it. No more detail on the video than that. To give you an example, let me see. This is a good example of, so like this is my Cal 2 class, day 3, 4-7, chapter 4, section 7. This might be loud. Be ready. Nope. Okay. This just gives you an idea of what the videos. Oh, that's kind of blurry. That one came out kind of blurry. Oh, well, I didn't wait long enough. There we go. It's decent quality. 720p, it's good enough. You can make out what's going on. You can hear me. You'll get sick of my voice. Sure. All right. Anything else here? We have discussion board. That's a place where y'all can talk to each other. It's a public forum between your classmates. If y'all want to go there and have any discussions, go ahead. Your grades at various points, your grades will start to appear here. All right. And then this BrainFuse online tutoring is a tutoring service that we've had at this college for about a year or 2 now. Not a single student has ever given me any feedback on that. But it's apparently someplace you go and you can connect with someone 24 hours a day that has an online whiteboard, and they can like go back and forth with you. But they are not connected directly to our college. So it's really just some person who has a master's degree in mathematics that's just waiting for someone to ask a math question somewhere. So the explanation that you would get from that may not fall all in line with the explanation I give. But it's there, okay? It's a resource. Do we have any questions? I'm ready to go. I'm ready to do this. think I'll bring the packet back up. All right. I do have a sign-in sheet. So I will be taking attendance every day. And the attendance is, you should find your name and then today's date and just initial in the little box. All right? And then pass that around. Make sure you sign this every day, all right? So if you don't sign that, I'm gonna say you weren't here. If your name is not on there, let me know. So what are you all thinking about this? College algebra, math 13, 14. Y'all excited? Anyone? Okay, so how many of you really enjoy math? Yeah. How about like hate math? Anyone want to go that far? Okay, good. So you're being honest. Hate math? Strong. That's a strong feeling, right? Very negative vibes. How many of you are just like okay with math? Like, let's just do this, get this over with? Okay. All right. So here's the way I'm approaching this class, right? Many of you are not going on, right, to do more math. And so you need this course just to kind of check off a box, right? There were many courses I had to take that I did not like either, like English. And when I had to write research, history, right? Stuff already happened. I don't need to know this, right? No, right? So we all in a college education have something that's going to be a hurdle for us, right? It's going to be something we don't enjoy. So this is, for a lot of you, that course. And I know that. You know, I know that you're not going to be building a bridge I'm going to be driving on in 10 years, right? Hopefully, right? So if I were to approach this in the sense of you're all going to become engineers, my standards would be a lot higher than they are going to be in this class. I want every one of you to succeed, all right? I want you to learn, because if you hate math, I want to try and make it at least a little bit enjoyable to you, right? Just a little bit. And the biggest thing I expect from you is effort, okay? So if you try and you fail, that to me means more than not trying and failing. So I will hopefully see that from each of you. And the biggest indication is homework, right? If you sit here and watch me and you're like, I already know how to do that, I'm not going to do the homework assignment, you've already made the first mistake when it comes to effort. Because even if you know how to do it, doing it yourself is different than watching me do it, right? Because when I come up here, hopefully, I'm not going to make any mistakes. And that's the downside of it, is that I'm not going to get lost the way you will get lost, right? So when you watch me, I'm not ever going to go down that wrong exit and get into some bad neighborhood in mathematics where I never get back, right? And that's the biggest problem when it comes to math, and that's what makes people hate it, is they don't have that confidence to keep going down the road in the correct direction. So try, and you'll be rewarded for that. But if you don't try, I won't have much sympathy at all for you. So when I come in and I say, I want to see your homework, you can't tell me, well, I worked. Right after class, I worked, and I didn't have time for the homework. Because my response to that will be, what do you think? I don't care. No. What do you think? Come on, you're me, and you're asking your student to do their homework, and you come in the next day and they haven't done it, and they give you the excuse that they had to work or something like that. What do you think?
Did you work all night?
Did you work all night? Okay. Why are you here then? If you have to work and you know you don't have the time to put in for the class, then you should not be in the class. There's a difference between enrolling in a course and actually doing a course. So just showing up here for 2 hours, 4 times a week, is not enough in this course. You must be able to go home and do your homework, especially because we're coming back the next day. So the stuff we do today, you will have had an opportunity to master in some sense and to raise any of those questions in yourself and bring them to me next class. So I'll start class next time. I'll be like, any questions over the homework? Dead silence means everyone's perfect or shy or a lot of people didn't do it. Yeah? I feel like I'm babysitting here. Sorry if I come across that way, but I think it's important for you to know that I do care about your success, but I don't have tolerance for no effort. All right. All right, so let's begin. The way I think I'm going to do this, because this should be somewhat review, is I'm going to start working through some of these problems. Then I'll give you an opportunity to do some of yourself. And I'd like to get some dialogue going because I want to know where people are. And if I keep on turning around, no one's responding, I'm going to just start calling on people, and then you don't want that, right? But if you're like that one person that answers everything, you know that person in the class that you're just like looking out of the corner of your eye, you're like, okay, please understand that as a person who would know everything, that you should probably let other people have an opportunity to gain that confidence that you have, all right? So I hate to tell people that's enough, but I will say, how about, next one or something like that. All right, so let's look at number one. What I'm going to try and do is try and see if I can squeeze out of you mistakes, things that people do that are common errors. So let's do this first one. And I'm just going to write it down the way it appears. Here we go. First thing, what are they asking you to do? What are you being asked to do? Perform the operation indicated below, right? All right, so is this an expression or is this an equation? What's the difference? An equation must contain an equal sign in it, right? I don't see an equal sign, right? So this is not an equation, this is an expression. And so what we want to do is perform this operation on this expression. So we're going to take this expression and turn it into something else. That's all we're going to do. The operation they want us to do is indicated by that dot right there, which is multiplication. That's implied multiplication, right? So how do we multiply these two things that we call fractions? How do you multiply fractions? Do what? Cross multiply. Straight across multiply. Anything else? Reduce. All right. So let's take kind of a vote. How many of you have heard cross multiply before? You've heard it, cross multiply, right? When you cross multiply, what do you need to have in order to do cross multiply? You have to have an equation. Cross multiplication comes in play when you have an equation, all right? So we can't do cross multiply here because you don't have the equation. Now I heard straight across also. How many of you have heard multiply fraction straight across? Yeah? How many of you have heard reduce a fraction? I'm just looking for like language here, yes? All right, straight across and reducing are both valid. We could do either one here. So it's kind of like if you're going to go from here to Austin, there's a couple of different ways you go, right? You go 35. There's a way to get there 281 also, right? So we want to get to an answer, and there's multiple paths to get to the answer. The good thing about math is that as long as you don't break any rules, you should get to the answer. Some paths are longer than others. Some get you right there right away. So I'm going to do this one two different ways. I'm going to reduce it, all right? First, I'm going to do that one, and then we'll do it with just the straight across multiplication. Just look at the differences. We'll get the same answer. We'll see if one was better than the other. All right, so reducing, what did you mean by reduce? Go ahead and tell me what you would do here. I'm looking at you, but anyone.
I would reduce the 4 into 16.
The 4 into 16.
Instead of 1 into 4.
Okay, so you turn this into a 1 and this into a 4. So what you're doing here is you're using the fact that because it's multiplication, you are allowed to do this, yes? You're allowed to say, okay, do any numbers go into 4 and into 16? 4 goes into both of those, right? Now, could we do the same on the 3 and the 9? Yes. So if we wanted to be a little bit more technical about this, I'm just writing this down, okay? This separation of multiplication doesn't have to be there. You could write this as one fraction with multiplying on top and multiplying on bottom, right? And then you can do this. I know you're going to sit there and look at, some of you are going to look at this like, why is he doing all of that? Like, I already have the answer. Got it. Okay, fine. If you're there, that's okay. I don't need to see all the work for it, but I'm just trying to get us to see different versions of the same exact expression. This is the same as this, right? Multiplication straight across. This is the same as this, because all I've done is I've switched the order of these two. That's called commuting. You can commute when it comes to multiplication. You're allowed to do that. And if I look at it this way, I could, if I want, split it back apart. I mean, I could, right? And then these two fractions can be reduced because they each have a common factor. So I know this is not what all of you would write down if you were asked to do this problem. I'm just trying to get us to see some of the things that we can do with fractions. So I'm just going to write down now common factor. 4 goes into 4 one time, right? 4 goes into 16 4 times. So I could rewrite this as 1 over 4, correct? And then times still, and then here, what number goes into both? 3. So 3 goes into 3 one time, and 3 goes into 9 3 times, and you get 1/3. Now that they're reduced, let's just multiply straight across. 1 times 1 is 1. 4 times 3 is 12. 1/12? We happy with that? Now, that was me just like playing around. Some of you would have just done this. 1, 4, 1, 3, right? And just go straight across 1, 12, and you're done. And that's fine, all right? Now, what if we did not do this reducing and we just did the multiplication straight across instead? So this would have been another option, 3 over 16. So you just multiply straight across. 4 times 3 would give you 12. And 9 times 16. 144? Now, even though that is correct, it's not reduced, meaning you don't have it in its most simple form. So you have to find a number that goes into both of these. So you could try like 2, and then you keep going, and eventually you get it down to turn into this. Or you just recognize that 12 goes into 12 once, and 12 goes into 144 12 times. You get 1/12 again. Okay, we happy about that? This all right? Maybe I shouldn't use the word happy. Are you content with that? What's the difference between that and number 2? Division. Oh yeah, that symbol there, that division symbol. That's like the old school division symbol, isn't it? Isn't that the old school? I mean, we learned that very early, right? When we're learning arithmetic in grade school. That's like the first division sign we ever see. Have y'all ever noticed what that division sign really represents? Like what that symbol is? Like if I write 7 over 8, right? That's division, isn't it? But I could write anything over anything, right? I could write like anything I want, question mark over question mark. That would be a fraction, right? Or I could just say like dot over something, like that over something. Like anything over itself, right? So that's what a division symbol is. It's just a fraction, but top and bottom are represented by dots. So So we're going to do this fraction divided by this fraction. So what's the rule here? Straight across? You have to flip it, right? Flip what? The second fraction has to get flipped. Okay, so that's the rule when it comes to division, is that you will convert it from division to multiplication. This becomes 9 over 2, right? This switches, right, to multiplication, but this guy right here flips. What's another name for a fraction that you've flipped over? Like 2 over 9, this 9 over 2 is called its what? Reciprocal. All right, so you're going to multiply, you can change division to multiplication, you're going to multiply by the reciprocal of this fraction. And now you're back to multiplication, you can go straight across. How about reducing? Can we do any reducing here like we did it before? Can you think of any numbers that go into 7 and 8 other than 1? No? Any numbers that go into both 9 and 2 other than 1? Any numbers that go into 7 and 2? No. Any numbers that go into 9 or 8? No. So this is it. This is as clean as it's going to get. Straight across we get 63 over 16. Now does this reduce? Does that reduce? I mean, I could turn it into a decimal. I understand I could do that. But is there a number that goes in both of these? No. And here's why. If there was, it would have happened here too. And since these didn't reduce, this won't either. So there won't be a common factor of both of those. All right, let me ask you this one. This one's not on the sheet. But what about this? How about 3/4 divided by 2? Okay, so you're going to recognize that 2 is actually a fraction. That way you can do the reciprocal. So the only thing I'm doing here is just rewriting 2 as 2 over 1. And now I'm going to convert it from division to multiplication. And that'll become what over here? 1 over 2. And does anything reduce out here? Any numbers that go into both of these or those or those? No? Straight across, 3 times 1 is 3, 4 times 2 is 8, 3/8. That okay? Sure you don't have any questions? If I'm killing you with how easy this is, I'm sorry. This is where I have to start. Okay. All right, so let me try and push this a little bit further. What if I wrote that down? Let's have some votes here on what this means. How many of you think that this means this? Show of hands. Okay. That means everyone else thinks it's something else? What else could that be? If it's not this, what else could it be? It could be 3 divided by 4 over 2. Do y'all see, does everyone see both of these seem almost like you could say either one? Yeah? So which one is it? You just get a coin out, flip it, heads or tails, right? No. This is bad notation. The way I wrote this on the board is incorrect. I have to be a better mathematician if I'm going to write something like that down. What I need to do is make one of these bars bigger than the other. If I don't, there's a problem in my presentation of the problem. So let me show you how I get this one. Okay? To get that one, I make the division bar here bigger. All right? So what this means is that you got to do all this by itself, then divide that by this. So all of the 3/4 by itself, then divide that by the 2. Do you all see that there? This one, I would write 3 big division bar 4 over 2. See, the smaller division bar is on this one. Okay. Why don't you try 3 and 4? They're up there. See if you can do 3 and 4. You should make some friends in the class, you know. You're going to be here for 5 weeks, almost every day. When you get 3, raise your hand just real quick, and okay, and then move on. If you need help, raise your hand or something. I can come assist you. All right, what you got?
Since nothing goes into each other.
If you can think of a number that goes into both of these, then you would reduce or these. So let's just think about, is there any number that you can think of that goes into both of those? Okay, so like 2 doesn't go into both of them because they're not even. 3, only 7 goes into that, right? I don't think 3 goes in there, so, or does it? 8, right? So you could do 3 into both of those. You could try, those are both even, right? So try 2 into both of those. And so you'll rewrite this fraction and that fraction next to each other again. Would you like me to put the answers up just so you can see if you're getting them? Yeah. Now I'm trusting this answer key is correct. I'm going off of what was provided to me, but I will double check them because I don't trust it. How many of you got 1/2 for 3? Okay, that makes me feel good. Anyone get 4 over 21 for 4? Okay, good. All right. In terms of timing, I think where we are right now is about how much time it should take you to do those 2 problems, give or take a minute or so. All right. If you're still working on 3 or you're still struggling on 4, then we need to identify right now that we got to get you to the place where you can finish that in a quicker time. That means there's some deficiencies, some holes that we need to get filled. All right? But I have to leave that to you as a student to reach out for that help. Another thing you don't want is when you see a problem like this to go grab your calculator. Okay, Okay? If you grab your calculator to do this problem, that means that that calculator has become a crutch. Now, if it's just a blanket you have to hold in your arms while you're doing the work, that's one thing. But if you're actually looking to the calculator to do the math for you, that's something that's going to haunt you throughout this class, right? We need to have a basic number sense, basic multiplication, division number sense. All right, I'll work through these pretty swiftly here. 3 was 21 over 24 times 16 over 28. Still have this one. Okay, anyone want to volunteer how they did it? Because there's a couple of ways you could do this. Anyone want to say what they reduced or canceled? Or not all at one time, please. Don't speak over each other like that. Okay, what do you got?
So I reduced the 21 and the 28 by 7.
So you recognize that 7 went into both of those. So you went ahead and knocked that out first. 7 went into here, 3 and 7 went into here.
And then the other
4.
way, I had actually done 8.
You did 8 into both of those.
Yeah.
Okay, so 8 goes into here twice and goes into here 3 times. Yes, that will work. Now you could have done 3 goes into both of these and 2 goes into both of those, or you could maybe go further. There's, again, different paths, same answer. Then you multiplied across
3 and 2 is 6.
6, and then
3 and 4 is 12.
12, and then you looked at that one and realized that that can go down further. 6 went to each of these. 6 goes in here once, 6 goes in here twice. That's one way. I won't do another way, but if you had a different way of doing it, you hopefully got it down to 1/2 also. Okay, the other one, 4/9. And I'm going to multiply and flip it, so reciprocal, 18 over 42. Now, if you don't flip it, right, you are not allowed to do that cancel, the reducing that we're doing here. You're not allowed to do that until you have flipped it and turned it to multiplication. If you do the canceling out before that, it's going to be wrong. So at this point, you can do some reducing. So what I see, just right off, I see 9 and 18, right? That's what I'm seeing. And then I'm thinking, does 4 go into 42? Does 4 go into 42? No, but 2 goes into both of those, right? Because they're both even numbers. So 2 goes into 4 twice, and 2 goes into this 21 times. And now I'll go straight across. 2 times 2 gives me 4, and 1 times 21 is 21. And that does not reduce any further. Right? Can't go in, nothing goes in both those. All right. Let's look at number 6. Number 6, they throw something kind of different at us. They have 1, and then they write a 4 over 9, and then they put a division symbol, and then they put 2, and then they put a 1 and a 4 like this. This right here is kind of different than what we were looking at before, right? I mean, it's got a special name for it. That one too, right? Anyone know what we call those? Mixed numbers. We call those mixed numbers. And you're going to see them used throughout the term here, all right? I am not a big fan of mixed numbers, okay? And the biggest reason I'm not a big fan of mixed numbers is because a lot of students don't have any clue as to what they really are. Let me try and illustrate what I'm saying. 1 and 4/9. That's the way you'd say that, 1 and 4/9. A lot of people understand that what that would mean is like if we're looking at this as like chocolate bars, this would mean you have 1 chocolate bar, right? And additionally, 4/9 of another chocolate bar. That's what that means. But mathematically, that's the same as writing this, right? It's 1 plus 4/9. So why Why we write it this way is out of convenience, all right? It's just convenience, but students don't realize that that's an addition symbol between them. That's all it means. And later on, if you were to take more math classes, like if you were in Math 14, we would tell you just never to use mixed numbers ever again, all right? So unfortunately, we'll have to keep them with us this whole time. But there is a way to convert this over, this mixed number, into what we call an improper fraction. Anyone remember how to do that? There's like this little trick to it, right? Yeah, you do this number times this number, 9, and then add that number. What the hell? 1 over the, okay, so I'm supposed to go 1 times 9 and get 9, and then I'm supposed to do what? Add 4 to that. Okay, then what? Keep the 9 on the bottom, like do this, like this, right? How many of you remember seeing something crazy like that before? And so this is really what, 13 over 9? Y'all seen that? That's a look of, yeah?
Wouldn't
Yep.
it be easier if we turn the 1, 1 into a 9, 9?
Yeah, that's exactly,
Cross.
that's exactly what happens here, okay? Look, this little trick of 1 times 9 and then add the 4 and do it. What's actually happening is that you're taking this fraction right here and you're rewriting 1 as 9 over 9. And the reason you're doing 9 over 9 is so that you can have the same denominator. And then when you add these two together, you add the numerators up and you get this. Now, we haven't done addition yet. That's the next thing we're going to talk about. But for us to do division of mixed numbers, what we will do first is convert the mixed number into what we call an improper fraction, and then do what we did before. So converting this over, we got 13 over 9 divided by, what is this one converted over? 2 times 4 is 8. Add 1, 9, over 4. So this is 9/4. Pardon? I did. I skipped 5. Sorry about that. I put 6 here, but 5 looked a little too trivial to me. Yeah, I won't necessarily go through every problem because of time. Now we play that same game, right? We go through cross now. Oh no, be careful, right? You got to flip first. So you're going to do 13 over 9 times 4 over 9. And now what? Now multiply across, unless we can reduce. But I don't think we can reduce. So what are we going to be at here? 4 times 13. 52 over 81. That's it. Box it up. Move on. Okay, so that's multiplying and dividing fractions in a nutshell. Addition and subtraction is actually more difficult than multiplying and dividing. So if you think back to like when you were first learning numbers, way back when, they taught you to add and subtract first, and then they taught you to multiply and divide. But when it comes to fractions, we actually do multiply and divide first, and then we do add and subtract because it's more complicated. So let's take a look at this first one in adding and subtracting fractions. We have, well, let me give you something else before I give you 1. How about this? If I give you 3/8 plus 7/8, because it's addition, what is the main thing that we want when you add or subtract fractions? What do you need?
Common denominator.
Common denominator, the same denominator. That means you need this to be the same as this, which in this case it is. And if you're there, then it's straightforward. All you do is 3, whatever this symbol is, 3 plus 7, which would be 10, right? Divided by, and you do not add the 8s, right? You just keep it, and you get 10/8. And reduce, something goes into both of these. They're both even. So 2, 5 over 4, box it up, we're done. So the goal of adding fractions together is to have the same denominator. If we have that, it's straightforward. I hope that's straightforward. So with that in mind, let's do this 1 over 8 plus 2 over 5. We recognize this is an expression, not an equation. It's addition, so I have to have the same denominator. So now we get to that place where I'm wondering what it is that you know. Like, what is the technique that you use? Because again, we're going to have different ways of doing this. So since they don't have the same denominator, I need to come up with something. It's called a common denominator, right? And there's actually one that we call the least common denominator, which would be the smallest number that is a multiple of both. What? The smallest number that is a multiple of both. So if you were to sit there and list out all the multiples of 8, 16, 24, 32, and you list out all the multiples of 5, and you try and find the smallest number that appears on both lists. What is it? 40. 40. Now you could write out those lists, right? But I'm not going to. 40. So the goal now is to turn this into a 40 and turn this into a 40. So how can I turn 8 into 40? Multiply by 5? So if I'm going to multiply this 8 by 5, I'm not allowed to just do that on the bottom, right? I have to do the same thing on the top. Remember that? So I'm going to multiply. I'll just rewrite it. I'm going to take the 1/8 plus the 2/5. And I'm actually going to multiply this 1/8 by, what are you saying I should multiply by? 5 on the bottom and the top, right? Now, you're telling me 5 over 5, right? Isn't that just 1, though? Right? Isn't anything over itself 1? But see, that's the whole key. Don't write this down. If you take anything and multiply it by 1, has it changed? No. But the way we're choosing to put a 1 here, by putting 5 over 5, we're actually being clever, and we're rewriting the 1/8 fraction in a different form so that it still is 1/8, but it just looks different. Instead of being 1/8, this is going to become 5/40ths. Now I have to do the same thing on this one. What do I multiply by here? 8 over 8, right? Which again is 1, which doesn't change the answer to the problem. So you get on top 16, on the bottom 40. Now we have the same denominators. And once you have the same denominators, all you have to do is go across the top, whatever this operation is. So 5 plus 16, which is 21 over 40. What's the difference between addition and subtraction? Like if I were to change this problem right now, if I were to make this a minus, then this would be a minus, right? And then this would be a minus. And then instead of doing 5 plus 16, you would do 5 minus 16. What is 5 minus 16? Uh-oh, negative numbers, right? Negative 9. Over 40 again. Do y'all see the difference between those two? I do expect that everyone here is comfortable with signed numbers. Like you can do 4 take away 13 and not need your calculator for that. So it might take a little while to get your brains going again if you haven't been doing that in a while, but you understand what I'm saying? Like, let me just show you. Like negative 3 plus 7, negative 3 plus negative 7, negative 3 minus negative 7, negative 3 minus 7. Here, let's just quick quiz on that right there. Not quiz, like just mental quiz. You ready? 4. Negative 10. 4 again. negative 10. Okay? 4, negative 10, 4, negative 10. So if you don't have those, if that's not working for you, again, just put an asterisk, you know, just be like, I need to go back and look at some sign numbers then or something. And that would be where you either come and see me or you go across the tutoring lab and say, hey, my instructor was showing me this, like I'm confused, and they'll help you get up to speed on that, all right? You want to try number 2? Okay. Try number 2, which is 7. It's a mixed number, 7 3/5 minus a half. If you've got it, just show me your hand real quick so I can see where people are. All right. Does that look right? That's what this little thing is telling me the answer should be, but y'all, everyone needs to like make sure they silence their phones, okay? Anyone not getting 41 over 10, like something's up maybe? Okay, this key could be wrong. I had already found, I started to review the key and I found an error on the first answer and I was like, I'm not gonna go through this whole thing, you know? All right, so let's see here. What do you do first? Turn it into an improper fraction. This one right here. So 7 times 5, 35 plus 3, 38, and then put that over 5. And then minus the 1 over 2. Now you're subtracting two fractions. You must have the same denominator.
It's 3 1/2.
Where?
2. Yeah, the number 2. This is different on this one.
Is it different on there? On what? The handout packet? Really? Okay. That's not good.
41 over 10.
Really? Okay. Oh man, don't tell me that. All right, let's see what happens here. Let's just go off of whatever problem I'm doing on the board is the problem that we're going to do. All right. What's the common denominator? 10. So I'm going to have to really like multiply this guy over here by what on top and bottom? 2, 2, and then over here 5 and 5. So I'm going to do that little multiplication on each one of those first and then see what happens. So 2 times 38? 76 over 10. So this equals 76 over 10 minus, and then over here, 5 over 10, which gives you 71 over 10. Yeah, I should probably just throw that away. It's good, good. You're nervous. I'm glad.
That's the one. That's the only one that has in the books.
It's okay. look, we'll all be okay. If you're doing some homework problems that are a little different than your classmates, it's okay. All the concepts are going to be the same here. So, all right, let's try one of these word problems, because I know that that's probably your favorite thing. And I would hate to not allow you to have some fun today. Now, I was sitting here, I was thinking while you were working on that problem on your own there, I was thinking, like, trying to go back and see if I could get inside your head a little bit while you're sitting here doing this arithmetic. And you got to, like, be asking yourself, especially the people who hate math, and I know there's a few people in here that told me they did. I think part of it is the fact that you don't really see any use for it. Or maybe I'm wrong. And the thing is, I will agree with you completely. And here's the thing, like, you got to look at all the math we're doing right now is the same as me walking in here with a hammer and a nail and saying, okay, we're going to put this nail into this piece of wood. All right, how many of you know how to put a nail into a piece of wood? All right, okay. Now, how many of you have ever used a Sawzall? Yeah? How many of you have never used a Sawzall? All right, so I'd have to maybe show you how to use a Sawzall, but it's just a tool. How many of you have ever done like MIG welding? Few? Everyone else never done it? I would have to teach you how to use that, right? All of those tools are used for something, aren't they? You could build a house, build whatever. Everything we do in here, all this algebra, is tools that we use to do more advanced things. And unfortunately, because this is the end of the road for you, not unfortunately, I guess you don't want to do anymore, that's fine, but engineers need these tools. They need to be able to use these things to build bigger things, right? Your phone, satellites floating around, cars that are smart, you know, all these things are pushed further and further by engineers. And these engineers have to be able to think a certain way, right? The way an engineer thinks. These are the tools they use. So it's kind of like when I was writing that paper on, that 37-page paper I had to turn in on some obscure culture, you know, and I'm sitting there going, kidding me? Like, no, I think I was typing it. You know, I'm like, do I really need this? Okay, well, somebody who's going to be in that field is going to need that. So why do I need it, right? Why do you need this? Why do you need this at all? Do we have an answer to that? No? You need this for your degree, right? You're never going to be, I doubt you're going to be adding fractions to, ever, right? And I doubt you're going to be talking about Dolores who sold some candy by the pound, right, in some candy store, right? So why do this? I don't know, man. Maybe we should just leave. Everyone come back August 11. We'll just, you know. No? Why are we doing this? Really? I'm asking you a serious question, right? Anyone have any answer?
I will be doing this, but not.
Not Dolores and her pounds of candy?
Oh, no, I'll be a teacher.
Okay. Okay. Well, if you're teaching it, yeah, that's a little different. Okay. So I'm going to give you an answer. It's kind of a loaded question. I'm going to give you my answer, all right? I have two answers. First answer is that you are a little circus animal and you are jumping through hoops, and at the end they're going to give you a piece of paper, and that piece of paper is going to allow you to do whatever it is that you want to do. And one of those hoops is a math class. And there's a bunch of other hoops. Some of them are interesting to you, some of them aren't. Right? That's one perspective on it. But there's something valuable in this. And that's the person who has that piece of paper, when they're going for a job, that piece of paper shows that that person is teachable. All right? You can learn. So if I have a position, I have someone who doesn't have that piece of paper versus somebody who does, what I can tell you is that that person can learn various skills even if they don't like them or they don't excel in them. They have a rounded education. They can do various things. Understand? Now, that doesn't mean that's going to be a better employee, right? That doesn't mean anything really. but it gives that assurance, right? That little bit of assurance that that person can learn. Got it? Okay. So that's part of why we're having to learn this. The other part of it is just the fact that people are so different, and like what's beautiful to you and what's beautiful to me are different things, right? And there are some people that find this very, very beautiful and very rewarding, and you're just getting a little glimpse into it. And if you don't like it, you don't like it. Just like I didn't like reading about cultures I didn't like, right? But I did learn a little something about it, and I learned to have some respect for it, and that's part of what education is about, all right? Okay, sorry. Let's talk about Dolores and her candy store, because I think that's, you just want to know what you're going to need to do. So the most important thing on word problem is to turn the word problem into a mathematical problem. And it should match up pretty well with what we've just done. Dolores sold candy by the pound. The first person came into her store, bought, and see, this is already bad notation, but this is what they mean. 2 1/4 pounds of gumdrops. The second person who came into the store bought 5 3/4 pounds, 3/4, of jelly beans. These people are buying a lot of candy, right? That's a lot of candy. How many pounds of candy did Dolores sell to her first 2 customers? So what do we want to do? Add those 2 together, right? And that's it. I'm not going to go through the work, okay? I'm going to say ... because that you would convert those to improper fractions, just do what we've been doing, right? Okay, what about the next one? Language arts class. The class was assigned to write a team paper. Each team was to write 5.5 pages for the combined paper. When all teams put their papers together, there were a total of 44 pages. How many teams had worked on this paper? So how are you getting that?
5 times 8 is 40. 25 divided by 2, which is half.
Okay.
4.
So you're doing just a mental calculation. Let's see if we can turn it into something we've done here today.
44 divided by 5.5.
So the paper was 44, right? And you wanted to divide that into groups. Each group did 5.5 pages. So if you take your 44 pages and divide it by the number of pages, which was 5.5, then that would be the computation right there. Again, ... meaning I'm not going to do that. I will give you one hint. The 44 is going to need to be turned into 44 over 1. And then you do this one to your improper, and then flip, multiply, and you should be there. Questions on what you would do with that? Any questions on the interpretation of the problem? How about Dennis and his dog? What? 127 3/4 pounds. It's a little chihuahua, I guess. The dog weighs 127 3/4 pounds. His friend's dog weighs 97.5 pounds. How much more does Dennis's dog weigh than his friend's? So what is the operation you're going to do there? Subtraction. Which one is subtracted from which? 94.5 is taken away from the 127. So you write it this way: 127 3/4 minus 94 1/2, and that should give you the difference in their weights. Both of those have to be turned into improper fractions, and then so on and so forth. Okay, that's all I'm going to do for that. Let's move on to the next section. Order of operations. All right, so order of operations. I will review this quickly. Because this is important. I'm going to put something on the board here and we're going to take a poll, and we're going to see what we get. So everyone, I want you to compute this for me. Another way I could have written that is like this. That's the same thing, using a slash instead of the division symbol. I want you to do 12 divided by 4 times 3. Everybody there? Everybody have an idea? Okay, so I'm not going to hold this against you at all if you get this wrong. Anybody want to tell me what they got? What? 1 is, okay, that's a very common answer. That's a 1. And yeah, the other one I always hear is 9. 1 and 9. Anyone get something else? Okay. You should get 1 or 9, all right? So should we do a hand vote for this? Do you want to know? Okay, let's see. 1s. Up high. Okay. 9s. It's all right if you think it's 9s. Okay. All right, so we're going to have some people learn something today for sure. All right. So for those of you who said 1, how'd you do it? You multiplied, what, these two first, and got 12. And then you did 12 divided by 12 and got 1, right? Okay. Raise your hands again. All my 1s? Whew. Okay. Now my 9s. There were only a few. Where were they? You obviously screwed something up, right? What did you do?
Divide first.
Okay, well, wait a minute. Why did you divide first? You're right, okay? You're correct. But why did you do it?
That's the order of operations.
That's the order of operations, but all these other people did it the other way? You got to feel like you're wrong, right? How could this many people be wrong about 1? Anyone else have? Whoever else got 9, what's your...
I just, when it came to like the PEMDAS thing,
Yeah.
I mean, add still comes before subtract and multiply still comes before divide, like in the word. So I think that's always screwed some people up.
That's right, and that's why I want to talk about it today. Because the correct answer here is 9. All right? Let me explain why. It's probably one of two things. You either learned it incorrectly, meaning it was taught incorrectly, or it was taught correctly but you weren't paying attention. It was one of those two things. How many of you have ever seen this? PEMDAS. Now there's all these little cute acronyms for this, right? Anyone have one of the acronyms?
Please excuse my dear Aunt Sally.
That's the one I learned too. Please excuse my dear Aunt Sally. All right? Anyone learn a different one? Okay, so we all excused Aunt Sally, yes? Okay, so this meant you always do what first? Parentheses, then exponents, multiply, divide, add, subtract. And that's cute, but it's obviously not working correctly. And the reason is because multiplication, division, and addition, subtraction are not done multiplication before division or division before multiplication. It's always whichever appears first as you read it from left to right like a book. So this is always in order of left to right. It is never, ever multiplication before division always. That is, throw it out, okay? That's not correct. Addition and subtraction, same exact thing, left to right. Now, I'm with you, okay? I'm one of those people that would have done this and got 1, okay? Somehow I got through my high school math and just, I learned it wrong or something happened, okay? The connection was never there. But I'm here to try and steer the ship straight for you, just like someone did for me. These are equally weighted, all right? So when you read this, you don't have parentheses, do you? You don't have any exponents. Exponents are powers, right? Powers on these numbers, you don't have those. So you come to multiplication, division. So you look for multiplication, division. Do you have them? Yes, I have both of them. Which do you do first? Read it from left to right. So this is first 3. Now you do your multiplication and you get 9. Now it's critical that that works. So if you have your calculator, if you happen to have it, I just want you to type in 12 divided by 4 times 3 on your calculator. Just do it real quick. And what does it say? 9? Because your calculator knows the correct order of operations. It's programmed in, it will do it correctly. All right? So a lot of people learned something today. You can't say you learned nothing, right? You learned something? All right. All right, so we're going to use this order of operations now, and we're going to do some simplification of some expressions. Let's see how this goes. For simplification, at your own risk. All right? Because here's the thing with the calculators. If you do it on your calculator and get it wrong, and you just have an answer that's wrong, I'm going to take everything off. If you show me your work while I'm grading your exams, because all your exams are going to be written exams. They're not going to be multiple choice. And so as I'm working through and looking at your work, I'm going to be looking for partial credit. I want to give you credit. You're demonstrating you know what you're doing. If you just have a wrong answer because you're just punching away on their calculator, it's wrong. If it's a 10-point problem, it's minus 10. So at your own risk, that means you got to be comfortable with all the parentheses and all that on you got to be real comfortable with it. So let me do number 1 on my page. I don't know what yours is going to look like, but 5 minus 3 plus 72 parenthesis 10 minus 2. Man, we only have 20 minutes left. I won't yap as much next time. I'll just be strictly business here. All right, do you see parentheses? Yes? So that means your entire universe becomes just what's in there. And now you start over. Do you have any parentheses in there? Inside there, do you? No? Exponents? No. Multiplication? Division? Addition or subtraction? Yes, so 10 minus 2 is 8. Okay, so I'm going to replace that with an 8. Now watch the way I'm writing this, because this is kind of like an English class in the sense that when I was taking that English class I didn't like, I had to use proper punctuation, and I had to put periods at the end of my sentences, and I had to do basic stuff. I would like to see basic mathematical handwriting that's decent, all right? Doesn't have to be top-notch stuff, but I need to be able to follow your train of thought. So I'm going to go from this line to the next line, and I'm going to replace this 10 minus 2 with 8, right? So let me just put an 8 there. Now, what is the operation that's occurring between the 72 and the 8? Multiplication. So I'm going to have to put a dot there. You could leave it in a parenthesis, like this, but then you just need to know that that's multiplication, right? So either way. Did I see another hand? Yes? Okay, yes, you could leave it in parentheses. But as long as you know it's multiplication, you could even do that if you wanted to. That's fine. Okay, start over. Do you see anything in parentheses? Well, if you wrote parentheses, you would, but there's nothing you can do with 8. It's just there. Exponents? No. Multiplication or division? Yes. Multiplication right there. Got to do that now. 72 times 8. 5 minus 3 plus, what is 72 times 8?
576.
576. Now you could use your calculator for that if you needed to. Okay, start over. Parentheses? No. Exponents? No. Multiplication? No. Division? No. Addition or subtraction? Yes. Which one first? In this case, we're going to do this first. Right? Left to right. So 5 take away 3. 2. 2 plus 576 is 578. And we are done. Okay? Let's try one that's a little more interesting. 2 plus 2 times 3 minus 6 minus 1 plus 1 minus 4 squared squared. And I know you're sitting there going, oh my gosh, that's just ridiculous. Trust me when I tell you that an engineer will face something like that. Someone taking higher math class will see that, and they will have to deal with it, and they will not be afraid of it, and then they'll move on, okay? Unfortunately, like I told you, you're just looking at the tools here in this class. Where do you begin? In the parentheses, but I see 3 parentheses. So I see this set of parentheses, right? Inside of that, there's not a parentheses. Over here is another set of parentheses. Inside of that is another set of parentheses. So where do we begin? You try and go as far in as you possibly can, all right? But we do have 2 sets of parentheses that are separated, aren't they? Like these 2? So I can do this one, and I can do this in here. Or I can do them separately. It doesn't matter. So how about this? I'm going to write equals. I'm just going to go 2 plus 2. Let me go ahead and take care of this. What's 3 take away 6? Negative 3. So I'm going to put negative 3. And let me go ahead and put that in parentheses. Now this is real important that you put that one in parentheses because you're about to multiply it. What if you forget to put the multiplication there? What if you don't write a parenthesis? What are you going to think that is now? You're going to think that's subtracting 3. But this has actually become 2 times negative 3. Over here we have minus, parenthesis, 1 plus. Now, what's going on in here? What do we get?
Negative 3 squared.
Negative 3 squared, like that. Put this in parentheses again, because it's negative 3 squared. Everyone okay with that? This and this. Okay, see, I'm not trying to bite off more than I can chew here. I'm just kind of slowly chipping away at this, line by line, moving down. The danger that people get into is that they try and do like 5 steps at one time, and then something goes off the tracks, and you can never really recover from that. Okay, so now I do have another set of parentheses here that I need to work on. Inside of that, I have exponent, don't I? This, exponent. What is negative 3 squared? 9. Side note here. Is there even a difference between these 2? Like, if I don't have a parentheses around this, like, is there a difference between these 2 answers? Yes, there is a difference. This means negative 3 times negative 3. What happens when you multiply 2 negatives together? You get a positive. This means, believe it or not, negative 1 times 3 squared. That's what that means. That negative right here is a negative 1 sitting in front of the 3, and it's not being squared. The square is only occurring on the 3. So this is actually negative 9. Parentheses are not just there for fun. They're there because they represent something. See the difference between these 2? So this right here is going to be a positive 9. So I write down all this junk again. There, like that. So I've just replaced this with this. Now what? Parentheses. In here, can you put those together? 10, right? So that's going to become 2 plus 2 times negative 3 minus, now this is going to become 10 squared, isn't it? Now this 10 squared, I can leave it in parentheses, or I can take it out. Either way, forget, ignore the negative there, right? This is going to be 100, isn't it? Whether you square 10, right? No matter how you square 10, you're going to get 100. Okay, what's next? Got the parentheses? exponent, so I'm going to square that. 2 plus 2 times negative 3 minus 100. I'm down to multiplication, addition, and subtraction. So this multiplication, what's 2 times negative 3? Negative 6. So that line's going to become 2 plus negative 6, which okay, I'll write that. Plus negative 6. I'd have to write it that way if I'm going to do it, though. Because we don't ever like to write like those two symbols next to each other without some separation between them. So you can either write it like this, or you can understand that adding a negative number is the same as subtracting. So you can be there. We're almost there. Left to right. 2 take away 6. Negative 4 minus 100. What's negative 4 take away 100? Negative 104. That's it. So that problem I did, let's see, 1, 2, 3, 4, 5, 6, 7, 8 lines of work, right? And if I were going back and looking at your work, right, let's just say right here, you would have had this. And then, you know, this would all be different, right? But what if I was going through looking at your work and I saw this right here and everything else you did correctly? How many points do you think I would take off? If this were a 10-point problem and you made that mistake, but everything else was right, how many problems out of 10 do you think I would take off? 1? 1 out of 10? 1 or 2? 3? 0? It would depend. It would depend, I guess, on how I felt. No, it's subjective, right? I'm thinking 1 to 2 points off. 1 to 2 points off. Which is why I would encourage you to do it that way as opposed to punching it away, because to me that's an error, but it's not it's not a big deal. I see a lot of other good work. All right, let's see if we can handle another one here. Don't be worried about wasting paper, right? Are we concerned about that? You want to save some trees? Look, you can do digital, right? There you go. You don't have to worry about paper. Are y'all worried about the trees? No answer, huh? I guess not. I guess you don't care. Okay. This division bar, okay? Remember how I said that division bar when I wrote those fractions and I said it was important that big division bar split everything up and it was bad handwriting on my part? Okay, that division bar really is doing this. Now, you wouldn't write this down, but I just want you to see this is what this division bar means. The division bar means separate this numerator completely from the denominator, do them separately completely, and then put them together. So I'm supposed to do everything up in the numerator first, then everything in the denominator next, then put them together. But I'm not going to write it this way. I'm just going to work these out right here. So I'm going to ignore the denominator, bless you, and I'm going to do what's up here. So I'm going to do exponents first, 7 cubed. 7 times 7 times 7. So you get your calculator out, okay? I mean, not everyone here is going to know what 7 cubed is. What do you got? What do you got? 341? Yeah, okay. I didn't hear you, I'm sorry. And then plus, can I do the 2 times 4 now? Yeah, I could. I mean, as long I'm doing order of operations, I do that and this separately, then put them together. So I think I'll do 2 times 4 is 8. On the bottom, I'll do that. What do you have down there? 14? Add up the top. 351 over 14. Does 351 go into 14? I'm sorry, does 14 go into 351, or is there any number that goes into both? I don't think so. The only numbers that could possibly go in are what? 2, because 14 is 2 times 7, right? So 2 doesn't go in each one of these. And 7, those are the only factors of 14. So 7 doesn't go into 351. So we're done. Now these get kind of messy, all right? They get fairly messy. And I think because this is the first day, I'd like to see how you handle these topics. Because again, these are review topics. These are not like welcome, this is the first time you've ever seen this. You should have some exposure to this. So I think it'd be good exercise for you to go home and do these homework problems. What I'm going to say is on your homework, you're going to do on homework where does it start?
Page 7.
Simplify, yeah, 7. Homework. Stop at page 12, part B. So for the homework, it'll say on their homework, let me show you up here. All right, so when you get to the homework problems, it'll say it up here, homework, fractions. So there's fractions with some word problems. And then the next one, page, I think it starts on 11, is homework, order of operations. So you're going to do those. But when you get to part B, it says solve the following equations. Don't do those. That's where we'll pick up next class. We're going to solve equations. But I want you to do all of these. And see, those look pretty ugly. Some of those are pretty nasty. But you just follow your order of operations, and you should be all right. I expect to have questions next class when we start, like, can you help with number 12 or whatever it is? Where's the sign-in sheet? Did that get around to everybody? Does everyone understand what they're supposed to do for next class? Have all that homework done?
7 to 12.
What's that?
Pages 7 to 12.
I don't know if it's 7. Let me look right here. 7 to 11. Order of operation.
Yeah, that section B starts on.
Yeah. So page 7 has your homework for fractions. And then page 11 has the homework for order of operations and linear equations.
Just those 2 pages.
Just those 2 pages. Yep. All right, everyone. Have a good day. You too. Yes.
The scientific calculator required for this one?
What's that?
The scientific calculator is a TAD1 already for it. Is that required?
What do you have?
I don't have anything.
You don't have. This is what you're supposed to have.
Okay.
It's just scientific, though, is really what you need. But if you're going to go buy scientific, I would just get this one. You should be able to get that for like 10, 12 bucks.
Okay.
It's in the syllabus, TI 30XS. Let me turn off my camera real quick.